Welcome back. Let's do number 6 and 8. Number 6, a 92 kilogram, 25 meters. What is the net force exerted on the skier, assuming his acceleration is constant? I'm not going to draw a picture. The mass is equal to 92 kilograms. The next thing says that the initial is equal to 0 to a speed, so that means final velocity in meters. And what do they want? They want force. Okay, the bottom stuff is all grouped together because I've got to use kinematic, so that means v final squared plus 2 times the acceleration rate. Solving that for the acceleration rate is v final squared minus v initial squared divided by, and at the point I might go ahead and say that, oh, that part's 0. Is that gets squared, and by 2 times 20. So we have 12 squared divided by 0.88. It's okay to have extra since this is a middle of the problem answer. Is the sum of the forces is equal to the mass multiplied by 92 kilograms was 2.88. So that last answer times 92 gives us, with 2 sig figs, that's going, so 260 newtons is the answer for number 6. A 42 kilogram parachutist is 3.85 meters per second. That is his initial speed. The initial equals 3. If the parachute over a distance of 0.750 meters, they said constant UAM equations. The distance is equal to 0 meters. What force does the ground exert on? They would like to know not the net force, but the force by the ground. All right. Now, for starters, what we are talking, the parachutist landing is actually what little bit of movement happened. Delta Y is actually a downward movement, so that should be negative. The initial was downward, so that should be negative. And gravity is, of course, negative g, so negative 9.81 meters per second squared. We need to figure out the acceleration. And wait, hold up a second. Stopping problem. So this is a mistake that a lot of people make. So we are trying to again, actually the same one we use. V final squared equals v initial squared plus 2 times the y. Solving that for the acceleration, the final velocity is v final squared minus vy final and vy initial divided by 2. V final is 0, so I've got negative v initial squared divided by 2 delta of negative 3.85 meters per second getting squared divided by 2.750 meters. Okay, so 3.85 square that, then make it negative, divide it by 2 and divide it by 0.75, which was negative, gives us, that's a coincidental value from the last problem. So our acceleration in the y direction, 9.88. So start a fresh piece of paper because that was longer than I expected. So I'm going to keep this and keep working. We need to know what the force was on the person. Well, that got all polluted. I'm going to draw the parachutist as a box just to make life easier. We have multiple forces. The weight of the box, which is downward. And then we have, well, forces. We have the weight, which is downward, and we have upward, which by definition is the force applied by the ground. That's the thing that we're trying to find. Situation, we do not have, so the sum of the forces equals the mass that's involved multiplied by the acceleration. The sum of the forces is the normal force in the upward direction equals the acceleration that we calculated a moment ago. Mass is, weight. So when I add I end up with the normal force is equal to the mass times gravity. So I'm going to factor that out and say the rate of acceleration from gravity. Okay, now we're getting somewhere. But I didn't write it down. Where's it at? 42.0 kilogram parachutist. 42.0 kilogram parachutist. The acceleration 9.88 plus we're not calling this negative as a magnitude in order to give us weight. So that is plus second squared. In other words, the weight plus, so that does make some sense that it's going to be more than her weight. And so 9.81, and we end up with 826.27 newtons, and if we want to be upward. And that's the end of number 8.